Welcome to Nick Does Maths with me, Nick, right here. And we are going to do some mechanics. We haven't done some mechanics in a little while here. As usual, mechanics tend to be very wordy questions, so I've tried to summarize it with the picture and a few key points. We've got a vertical circle of radius A, made of wire. We've got a bead of mass little m that's just sliding around this whole thing. And there's a string going from our bead of mass little m through the middle of the circle. There's a hoop there or something, and then it comes down and hits another mass of mass capital M. Now our little bead is projected from the bottom of the circle at a speed u, reaches the top at a speed root 12 ag, and I should probably put some units in there because I'm a good boy, meters per second. And it's able to do full revolutions. We want to get to this condition. So there's a lot going on. We're going to need some colors. Got it. And let's start labeling some forces. Now, first of all, just in general, let's just label that theta. That's quite good. And let's label some forces. Well, this one, of course, has capital Mg and tension coming back there. Now, the bead on the hoop, there is obviously tension. And it goes without saying, the string is light and inextensible. There is mass mg right there. And there's also a reaction force from the wire onto the bead. All right, now, so long as the bead is moving around, it wants to go this way, which means the reaction force is going that way. Okay, we might want to add in a few, like sort of course, a reminder that that's theta. And at any point, let's just say that it's going at velocity v, and we'll deal with that afterwards. All right. So by and large, let's use the fact that we know what's going on here. So as usual, with vertical circles, we're going to rely on energy quite a bit. So let's rely on energy quite a bit. So at the bottom, let's just take this as my zero height, okay? So it has kinetic energy. It has half mu squared. That's how much kinetic energy it has at the bottom. At the top, it has half m. That's its velocity, squaring it. But it also has picked up some GPE, some gravitational potential energy. Now, that is A, so that is 2A. And now, this is going to give us something nice for you, I do hope. So what's that? That will give me u squared, that is 6ag. U squared is equal to 16 ag. 6ag, 2ag is 8ag times 2, 16ag. All right. Now, why is that important? Because that's going to give us our base level of energy that we're going to work with. Right. Now then, what else are we going to play with? I mean, at any given point, we could have a look at something about V. Now, when we're at theta, for example, so this is my start and bottom. So how about when we're at a generic point theta? Well, the total energy is going to be, the total amount of energy is half mu squared, which is 8mag. So that is my base level of energy. Now, instead of looking at what's going on at the top, how about we just look at a generic point? So that will be half, the m's are going to cancel out, but I'll put it in half mv squared plus mg. Now our height at this point will be a minus a cos theta. All right, and we can see that all we did up here is we plugged in theta is equal to pi. Theta is equal to pi is when we're at the top, and that will give us this. Now, I put the m's back in. Turns out didn't really need to, but there we go, for completeness sake. So where do we end up? I end up with half v squared is equal, there's an ag there, take it over, that's 7ag, bring that over, plus ag cos theta. All right. V squared is 2ag, 7 plus cos theta at any given point. All right. Okay, we've stayed away from it for long enough. What can we do now? So we're just going through our checklist of things what we can do when we're playing around with circular motion. Well, now we're going to have to go for our good old F equals ma. So our radial force, what is providing my centripetal force? Well, we got the tension, we got the reaction force, and going outwards, we end up with mg cos theta. And that has got to equal to mv squared over r. Our centripetal force formulae for circular motion. Well, okay. Now, the thing is this is going around a circle, so the length of this is not moving, right? The length of this string does not change. That stays at A, that goes there. So I want T is equal to capital Mg. So I can start plugging some stuff into this. Capital Mg plus R minus mg cos theta. Now, mv squared over A. Oh, I need to be a little bit careful with my capital M's and lowercase m's here, don't I? All right, so that's lowercase because we're looking at the bead. All right, so here we go. Divide it by A times by M, so we end up with 2mg, 7 plus cos theta. Well, okay then. We could tidy this up a little bit, I suppose. mg Well, actually, let's have a look at this. So, what's going to be happening here, right? We'll just go mg plus r and see what's going to happen here. Because 14mg, 2mg cos theta plus another 1 plus 3mg cos theta. Now, what do we want? Well, there are limits to what capital M can be whilst this thing still goes round in circular motion. If m is too small, what's going to happen if m is too small? This weight will move up, this string will shrink, that will muck about with the tension. None of this is valid. So we can't do that. If T is too heavy, right, nothing moves. Now, our real limiting case here, is all to do with R. What is the smallest value of R I can get? If everything is swinging around as smoothly as possible, well, I want R to be 0. So we're going to whack in R equals 0. So what's going on when R is equal to 0? Okay? Why is that? Well, I mean, this I can't do anything with. Little m is there, little m is there. I mean, that will go, basically, we're going between 17 mg and 11 mg. Essentially, we're going between 17 mg and 11 mg. And the idea is this, is R, if I increase m too much, R will just blow up. And then this can't be anything at all. Right? So, let's set R as 0. Let's get R as small as possible. So, we get mg. And in fact, the g's will cancel out, but that's okay. Let's cancel out the g's. Bomb, bomb, bomb. And as we can see, cos theta is between -1 and 1. So the smallest value of capital M is going to be 14m minus 3m, which is 11m. And the biggest it can be would be 14m plus 3m, which is 17m. Et voila, exactly what we wanted. A little bit of mechanics getting us back into the mechanics, and especially with vertical circular motion, we have to like make heavy use of energy to get some cool stuff. We still bring in the equation of motion. Bosh bosh, isn't that fun? Don't forget to like, subscribe, leave a comment, let us know how you're vibing on your mechanics as we start working towards this. This is very much further Mech 2 probably, depending on your exam board, with our vertical circles. 'Tis me, Nick. I will see you soon. Hope you enjoyed it. Toodle pip.